So good morning, everyone. So let's talk about detecting and classify object images using Ruby. About myself, so my name is Fabio Leandro. You can find me using my nickname, Fabio Semi. I'm from Brazil, so English is not my first language, so feedbacks are welcome, please. And also I am software engineer at CodeMiner 42 company. At CodeMiner, we are a software boutique company that we can handle and help you with any kind of web application, mainly our Ruby on Rails application, but feel free to reach us and contact us if you need some help in your team or in your web application. All examples that I'm using today are available at my GitHub page in the repo called RubyConf 2024. The QR code is to the repo. So I will talk about my research overview about the digital image processing, Ruby options that we had at the time, also object detection, supervised classification, and what else we're gonna try to do, and what else you can also try. Okay, so my master's degree research are basically, we collect some soil samples in the field, in the farms, or whatever is the place. We send to the lab, they send to us the chemical information about this soil sample. And with that, we also launch a drone with multiple cameras and sensors to capture the soil images. We collect the image, do some formulas in there, and put on a CNN and try to get a heat map about the chemical that are in the soil. So basically, we have like 10,000 of images. We try to glue those images. It's called the image stitching, and to have a orthomosaic, like a map of the field. And after that, we crop the image and create sub-images with that. And this is the process that I will talk about today. So digital image processing. Everything that we did on programming is not about the language, it's about the process. So for digital image processing, basically we have a way to represent the image that major of the times we are using arrays to do that. Like a grayscale image can be represented by single values for each pixel, and for our RGB image we have like for each color band we have a different value. And also those values can depend on the color space and beyond. So basically the pattern is to handle with digital images on a language programming, we can using this kind of process. And today we have like two major projects that are focused on digital image processing. That's called the ImageMagick and OpenCV. ImageMagick is more focused on the images per se, like cropping, doing some blur, this kind of stuff. And the OpenCV has the digital image processing there, but also is using to visual computing, like detecting sub-images and this kind of stuff. And since I'm from academia, also I'm a master's degree student, we need to look at publications and see what is going on the academia field. If you look at Elsevier and I3 publications, you got like 17 publications in the last 4 years using ImageMagick, but with OpenCV is more than 6,000 of publication in the last 5 years. So we choose to use OpenCV for our research. Okay, And OpenCV has a bunch of wrappers that you can use on C, Python, Java, and also Ruby. But sadly, the Ruby wrapper is too old. It's like the last commit is, I don't know, 8 years ago, maybe 7. So we had some choices to do. We need to define if you're gonna keep up with the Ruby wrapper, or I don't know, go to ImageMagick. The ImageMagick gem is up to date. Maybe create our own implementation since it's just a process, or call other OpenCV implementations from Ruby. So we had to make a choice. The other 3 ones were not the fastest way to reproduce some articles. So we found the PyCall. Please don't leave yet. I know. But yeah, the PyCall is to call Python from Ruby. Yes. The author is Kento Murata, and the first release was in 2016, and the latest release is from May of this year. Okay, so our problems are resolved. Okay, so to use PyCall, it's simple as that. You can load the PyCall import, include the methods, and using a method called PyImport. The PyImport will import the packages from Python, so you need to set up the entire environment, the entire Python environment, and install the Python packages that you're gonna use. In my repo, I put a Docker file there that created all the Python environment and install like the OpenCV and other tools that I will show you today. Okay. This is an example on how you can do a hello world using the PyCall. So the print is executed by the Python, and you have the object. Since the print is not like a value, it's just std out print. The value is new outside. Okay. So we have the Python. Now let's try the OpenCV. To load the OpenCV on Python is called CV2, and to load the images is simple as that. You can call the imread method from Python, and as I said before, it's represented by arrays. So this is an example of the RGB image. Well, in OpenCV is not RGB. OpenCV loads as BGR, so it swapped the color channel. Long story short, is about the history and legacy on the early 2000s years. Okay, so like the first pixel is represented by array with those values, and the range value is by default is 0 to 255, and is BGR. So this first position represents the blue color, green color, and red color. And for you to convert the BGR image to a grayscaled image, the CVT color is there. So it's a method from OpenCV. You can call it that. And all of these are executed by Python. But you can have the value on Ruby. So this is RB shell that I'm calling through Ruby. So the value at the end is 161. So it's just one value for the gray pixel. And there it is. You have a grayscale image. It's simple as that. Because we have the OpenCV working for us. Okay, so this is another example that you can just resize the image, draw a rectangle in there, and write the new image using the object from Ruby. Okay, So now we have a new image there. That's great. And this is the option that we have that we are thrilled about it, because we can separate all the pixels by his value, like splitting the image. So I have an image that represents the blue value, the green value, and the red value. For a BGR image, is simple as that. But for our research, we use like multispectral images with 10 color bands in the single image, like infrared, near infrared, and this kind of stuff. And with that, we can apply some formulas that we call the vegetation indexes. That is basically some formulas that the academic field provide for us, and man, we can create some indexes just doing this kind of stuff using Ruby. This is awesome for us. So basically, and at the end, we can apply a color map. So the raw image is represented by that, like a binary image, just 0 and 1s. But with color map, we can have a human view to identify whatever we want to identify in the image. For the maps and this kind of stuff, they are the same values, but this is more like for human beings. I see its image, and we can see whatever we want to see. And this is kind of stuff that we can grab applying multiple vegetal indexes formula. So this is the same image, and we can have like multiple informations based on a single part of the image, applying multiple formulas in there. All the formulas that I use in these examples are also in the repo. So that is great. We can use in PyCall to just load the OpenCV, but not just the OpenCV. We can use in some algorithms to detecting objects. We usually use supervised AI, to classify the images. It's not like full automatically AI, but it's more like, I need to focus. I need you to focus on this and this kind of classes. So to do that, we need to generate some objects there. And to generate objects, we can also use in OpenCV, like finding counters. You can apply a threshold that will find like some edges of the pixels, like the color space and this kind of stuff. So, as I said before, OpenCV provides all of this for us. And we can have like an image with like this, like all the green stuff are objects in the image. I applied this example for the RGB image, but if I use like the vegetation index image, I can have this kind of objects. So that's why we can apply some kind of stuff like that. And also we have other algorithms that can be like, for example, slide window is another algorithm from academia. That is just a slide that will crop multiple images in the image that you have. And selective search is also another way to generate objects. All of those algorithms are available at my repo. Okay, good. Right, we have an object. I can load on Ruby. I can extract information from there. But where is the AI? Well, you can use so many approaches to use a classify image, and like you need to see what the academia is using. go check the Elsevier and i3. But today, the hype is using deep learning, CNN, transfer learning, transformers, and this kind of stuff. It's basically the same approach that LLM uses to achieve the results. It's not exactly the same way, but it's some kind. Also, for images, you can check the challenges or benchmarks called the ImageNet, COCO, Ego4D, and Kaggle competitions. They are like the benchmarks for results of classifying images. Okay, so for this example, I'm using the Cafe deep learning framework. It's built by Berkeley University, and it's simple as that. You load the deploy proficiency. This is a JSON file that have the information about the layers and your model. The model is basically a huge array with a lot of random values that put the weight on the network to get the results. And then you can reshape the first layer. For this example, the data layer is the input to insert the image there. And basically, you can do whatever you want, but you need to define how many channels that you have and the window size of each image. And the Cafe framework have a transformer to like make a pattern about your image, like what will be the channels, what is the sequence of the color channels, what will be the values, what will be the size, and this kind of stuff. And you can just call it and processing the image right there. And to perform the evaluation of the image, you call the net forward, and you're gonna have a result. Each model will have your own layers to evaluate the results. For this specific case, the layer is named Softmax, and basically you're gonna have like the label names and the accuracy for that label. For the example, I'm just using like a high value of a chemical and a lower level of a chemical. For this example, it's 99% that is a lower level of the chemical that I'm evaluating. I have. So for this kind of stuff, I'm using aluminum values. So it's basically low level and higher level of aluminum. If you see those images seems okay, great, like you have a roof and maybe is high aluminum there, and you have a road that is low aluminum, but I grabbed the best examples of that, but as I said, sometimes the AI hallucinate those values. So yeah, we can have like all those scripts using Python that Academy provides the implementation for that, and you can use it on Ruby, and this is great. Okay, I show you how to use a model, but how can I train or build my own model? To do that is not a simple task because you need to evaluate that, and it's more like you need to build your own database and separate the images, visualize the results, and try again. It's a huge loop on that. So for such task, we use the NVIDIA Digits. It's a platform built by NVIDIA, and is not for Cafe. You can use in TensorFlow and other projects to do that. Okay, so I'll show you about the deep learning and some algorithms that you can use that. But also in the academia, we have a bunch of other algorithms to do that. Like K-means, SIFT, SVM, YOLO is another kind of deep learning. Also, basically as Euclidean distance. That like is more like trying to your problem, see the results, try again, change the thing, try again, see the results, and going on, going on, going on. So for us, the CAFE, we have great results using CAFE for images, but sometimes you gonna use like, I don't know, SIFT to use for audio, something like that. Okay. And the results for my dissertations, just to show you. So the best results that I have until now, I have for potassium, phosphorus, and organic matter. Like I have a 64 for potassium, 75% for phosphorus, and 74 for organic matter. Like, so this is the result that we are trying to achieve, creating some kind of heat map. But this is some way in fake, because the results is like a image with 10 color bands, and we cannot represent that for human view. So I just applied the color map that I showed before. Also, to correlate the image and his positions, we using two other packages that are called GDAL and GeoPy. We have both. We have similar packages, similar gems that can be used, but it's not like we have on Python Word. And also a great package to stack these multiple color images. We use raster.io. Future steps, you can try using TensorFlow. That is another deep learning framework and is made by Google and a lot of research, and have more tools that can provide for you. Also, we want to try to use Ruby Julia. Julia is another programming language, and Ruby Julia is something like PyCall. You can call the Julia language using Python. But we need a ton of work. Maybe in 2 years we're gonna try that. Also, we are testing for other elements. So I'm a liar. The message that I can put on the table is more like, great, Ruby is a great community. We know how to build software, but we cannot keep competing with another fields. Like the AI today is the baby steps of the AI. We are in baby steps for the last 15 years, but okay. And it's more like the academia is building that, and they use in Python. And we like Ruby, you know. It's beautiful. And I don't want to compare the language, but it's more like I like to be on Ruby. I like to use Ruby. So PyCal provides a lot of opportunities to us to bring what they are building for our world. Okay. I think that we have some time for QA. Any questions? Yes, please. No. For us is more agriculture, but we have some teams that are using for environment, like they need to see where we have some rivers, and like determine how much of trees we need inside of the rivers, you know, on the field. But like if you send the drone to the field, you cannot capture the rivers, because the trees will close the view. Okay. Please.
Did you use any special drones, or is it like an off-the-shelf drone?
No, we usually build our own. Like sometimes we use Phantom 4, and we just have the mount to put some cameras in there. But usually they build our own drones using, I don't remember the framework to do that. That's it. Okay. Thank you guys. Feel free to reach me.